evidence from that meta-analysis one way or another. I mean, maybe Avandia is bad and maybe does cause some heart attacks. I don't know. The point is, for evidence and the later evidence that came out, they've been arguing about this for 3 years, and the FDA has just now said, yeah, we're going to go ahead and put harsh restrictions on it. But the science that went into that decision was pathetic. One other good example that I want to give. This is from several years ago. This is antidepressants, SSRIs for kids. And there was a big deal about this. This is about 6 or 7 years ago now. I don't know. The FDA put the black box warning on SSRIs for kids because of the danger of causing the risk of suicide. And of course, what has happened since they put that black box warning on is suicide has gone up for the youth groups after years of decline. How did they reach this conclusion that they should do this? They did a meta-analysis. They got all these studies of these different SSRIs for the kids on who were being treated with them. And these were not trials that were designed to test for suicide, of course. They were efficacy trials. And so, but they went back to see if anybody recorded suicide. There were no suicides. There were some suicide attempts, and there were some reports of thinking about it. That's what they had. They had to add up the attempts and the reports of thinking about it. And they did the analysis, and they still didn't get any statistical significant indication. They had to add in a non-SSRI. If you look at the data, I don't know if you can see this, but there's no statistical significance for any of these, really. Paxil just on borderline, but Effexor, when they added that in, then they got an overall statistically significant indication of an increased risk of suicidal thinking. It's not an SSRI. They drew the conclusion about putting the black box warning on SSRIs by adding a non-SSRI into the data so they could get it to be statistically significant. They also had to add in all the trials for everything other than depression. If they'd have restricted it to the kids that were being treated for depression with the antidepressants, they couldn't get statistical significance. They had to add in a non-SSRI, and they had to add in trials that were things other than depression, which is not what the drugs were supposedly for. They were just being tried out. I mean, I think this is just, and then this is where they just used depression. The confidence interval is 0.84 to 2.37. Yeah, it's weighted a little toward the possible, and there might be. I should say, maybe there are some small number of kids you shouldn't give the SSRI to. That's a possibility. That's the study. But in general, the data here, it's not statistically significant data. They had to manipulate the hell out of it in this meta-analysis to get that conclusion. So I'm going to conclude by saying there are some pointers that I think all science journalists should know about dealing with these issues. They should know statistical significance does not mean significance. They should know that if the result is statistically significant, there's a good chance it's not significant. If the effect is not statistically significant, that doesn't prove that there isn't an effect. Averages obscure important effects. No one study establishes anything, and combining a bunch of studies is even worse. Then if I would then, after I tell the science journalists what they should know, I should say what I think the scientists should know. And if both groups kind of got together on these points, then maybe I think we would begin to make some progress. So I'll take questions.
Say you're a doctor and you know that the studies are imperfect. I mean, I know doctors may know for sure that when they're giving a treatment that it in a population will benefit only a few percent, and that in that population it may even harm people. That you have but that I have a number, that's all I have, and I try to convey that message to a patient to help give informed consent, but I think mainly, most people, probably you don't. I don't know what you do when you go to the doctor. What kind of evidence doctor? But a lot of people do, and they usually do what the doctor says.
You're absolutely right.
So what's a doctor to do?
It's a very difficult situation.
If they know all this, it would, which I think a lot of doctors do know all this.
Well, and I think you're right. And I think but the situation with doctors is very, very difficult because there's so much literature and so much contradiction and so much poorly presented literature. And the doctor's supposed to have another job like treating patients, not just doing literature reviews. So it's a very difficult situation. I think, good doctors, though, do know these things and recognize those things, so they have to apply judgment on top of what they see in the reports. And I don't envy doctors this problem because that's a problem I have to interpret this stuff, and I don't have anybody's diseases to cure or lives to worry about. So it's hard enough for me for a doctor. I feel for doctors on this issue like that. But what there needs to be is from somewhere. I don't know if it's governmental or if it's the journals or it's universities or whatever, some effort to do something about this general problem of crappy information flowing like crazy and produce some kind of a system for sorting out the good stuff from the bad stuff. And there are, of course, some journals and some review journals and things that try to do that in a responsible way that maybe would be where you would go. That's a terrible problem. Okay. Yeah.
Some of the better studies that look at lots of different studies will at least go through and rank, order the quality of the studies and have an inclusion criteria. How much does that help?
Well, what really helps, from my point of view, from the journalist's point of view, is if you have a review that's done, but it's not just a meta-analysis where they add up the numbers and do the numbers, but it's an actual review that actually applies some judgment to assessing the various studies that have been done. And you go through the end and they'll highlight what they call the most important studies and have a little annotation, why this was really good, or they'll have a little annotation about why this one is questionable. And they go through and you get somebody who's a very knowledgeable person who reviews the literature with some expertise and judgment and reaches what conclusions they believe to be sound based on understanding all these things, rather than just doing numbers. This is the problem with the p-value statistical significance. And one of the reasons I think it became so popular was it eliminated the need for a lot of actual thinking. You just put your numbers in, you got a number, and say, oh, I got a result. And that's not what really good scientists do. That's what the ones who they're desperate to publish maybe do. But a review written by someone with expertise and some judgment, and that's what's helpful. Yes?
So for people that do have to make decisions in the here and now and can't wait for another 20 years until the final word comes, they have to include the costs of misclassification. Or especially it's become important for AIDS patients, for example, who have very short timeline. We're willing to take greater risk, not wait for the final definitive statement. And so that's sort of what physicians have to incorporate, patient preferences and the risk attitudes. But that also flows over to journalists, that it's important to know the clinical significance as well as the statistical
Absolutely.
significance.
That's absolutely a key point.
And perhaps report things that don't even meet the .05 criterion, because that's for publication purposes, not for action on the part of patients.
No, that's absolutely right. There are a lot of times where there's something that doesn't quite meet the statistical significance criterion, but you have other reason to believe from other evidence, other lines of evidence, that this should be a thing that would be good to do. And because the study comes in and says, oh, it didn't quite make statistical significance, the FDA says, oh, tough, I guess we can't approve it because you got to have 2 trials that meet statistical significance. People should be saying, wait a minute, that's just an arbitrary and mindless way of doing things. If you have other reasons to believe something is a good thing to do, the fact that it didn't quite make statistical significance shouldn't deter you from thinking you should do it. And if you have, somebody who, you got to be careful because, anecdotal evidence is sometimes then people say, oh yeah, well this helped, somebody's sister, but that's also bad because you can't just throw out the data and stuff. You have to have people who can, like I said, use judgment and assess all the data from various sources and make some sound judgments about what looks reasonable.
So what Holly was getting at was that there's a fraction of statisticians, certainly, that applies more, that look at it from the Bayesian point of view.
Yes.
And I was wondering if you want to make a comment.
Well, that's the third talk in my series where I start talking about Bayesian statistics because, yes, there are obviously many situations, many types of studies, many kind of situations where Bayesian analysis is what makes sense to do. And it's not totally free from problems, but it certainly addresses a lot of these issues like whether I'm swimming in the winter, if you do a Bayesian analysis, you have to first know how often I swim all the time before you make any conclusions about the winter. That's the basic Bayesian principle. And applying Bayesian principles helps you avoid a lot of the most egregious misinterpretations. And there's there's a good movement around a number of people who are working hard on developing Bayesian clinical trial designs. The guy at MD Anderson, Don Berry, is a big proponent of this. And there are some now, even the FDA has gotten to where there are a few kinds of things they're willing to try. Maybe we'll do a Bayesian design. But that is definitely something that needs to be better appreciated and better understood. And the frequentists who hate Bayesianism should not be allowed to go to a doctor or something. I mean, it's like it's a long historical debate, and there's a lot of philosophical issues to get argued about. But however, you want to argue it on a philosophical level, when it comes to making some hard decisions about what makes the most sense medically to do, if you're not thinking Bayesian, you're going to.
One more question. Are you being effective in convincing your colleagues?
Question. Well, I've been reasonably effective and made a lot of progress with the ones who actually work for me. They're getting the message. They're shaking.
Or they don't work anymore.
Yeah, exactly. They're sorting out. Other publications, other places, I have tried to make this point, and I don't get quite as far with them. Yeah, but we'll see. Okay, here.
I'm wondering also, when you're talking about Avandia, I know it's okay, maybe there's more heart attacks, but that didn't seem to be compared at all with how many people's lives got saved.
Yeah.
There seems to be no reporting of the balance of that risk, especially with vaccine reporting. So
Yes, yeah, and that's one of the questions. See, that's one of the questions journalists should be asking when they write stories about this instead of just parroting what the study concluded. They should ask questions like costs and what benefits do you lose. They should always ask the question of, if the risk is increased, what was the risk to begin with that got increased? This is a real serious problem when you see a journalist just takes the papers like, this doubled the risk of esophageal cancer. And, well, if the risk to begin with was, 2 in 20,000 and now it's 4 in 20,000, that's relevant information for people to have a better understanding of how they should interpret that doubling of risk. Questions like that, the bigger context, it's critical to report this thing well. Yeah.
But can I
Yeah.
one more question? Because I've just been told that they need the room for some other purpose. We could then go to the math department if some people want to continue conversing with Tom Siegfried.
Oh, okay, we have one
more
last
question.
Last question.
So you referred to the situation where there's an anomalous result found, maybe it's something different. The investigators may overinterpret the data. They put out a big, press release, and the media's all over it, and it's on every radio show and everything. And then a well-done study that is better performed, doesn't overinterpret the data, is published, and the media ignores it. So, is there any solution to this kind of problem?
I've been trying to tell them, subscribe to Science News. Point out some of those problems. That's what I'm doing all I can to spread this word. But it's a tough task. Your observations.
Thank you again.